Hello, we're looking at the difference of two squares. Difference means subtraction, so you can see everything on the board there has a minus in it. And there's two things being squared every time. It's usually symbolized with a squared minus b squared. A is your first term, so a squared is your first squared term. B is the second squared term, so there's two of them. And there's a subtraction, which is the word difference. Difference of two squares. So we can see we've got three of them. Here our a is 10x and our b is 8y. Here the a is s, the b is t. Here a is 1 and b is y. Now everything that's getting squared should be inside a bracket. We don't often show the brackets. A lot of times we just leave them out. But everything should be squared. So this is what we mean when we say difference of two squares. On our last screen we saw what the difference of two squares meant. It meant things like this. We've got two squares, a squared and b squared, being subtracted, or something like 7y being squared. 7y is inside a bracket. Take away 8n squared. Again, the 8n is inside a bracket, so the 8 is getting squared, the n is getting squared. So my a here is 7y, my b here is 8n. So we're going to look at factorising them now. So factorising the difference of two squares. Difference of two squares will always take the form a minus b times a plus b when it's been factorised. So let's check that, let's see that it's correct. Let's multiply these two out, simplify, and we should get back what we start with. Because factorising and simplifying are opposites. So let's multiply that and simplify. So the a has to multiply both terms, that's happening here. The b or minus b has to multiply both terms, that's happening here. So let's do the multiplication. A times a squared. A times b, ab. That's plus by plus, plus. Now here we've got to be careful with our signs. Minus by plus will be minus. B multiplying a. Well, b multiplying a is ba, like here. But that's the same thing as minus ab. So they're the same thing. I'm going to throw minus ab here. So minus b by a has given us minus ab. Minus b by plus b, it's given us minus by plus is minus. B by b, b squared. Now, still does not look like what we started with, but we need to look at the plus AB and the minus AB. They're the same type of terms, they're like terms. We can add and subtract those. So if we have a plus AB, minus AB, that's going to give us 0. So they're going to disappear or cancel because we're getting 0. So we're left a squared minus b squared. That's my final answer. And that's what we started with. So factorising something, and then if we check it, we end up simplifying it, we get back what we started with. So factorising and simplifying are the opposites of each other. Looking at this one here, it looks slightly more complicated. It's the same thing. Here my a is 7y and my b is 8n. So it's going to be a minus my b and a plus b. It's still the same thing. Remember, a is 7y, so it's appearing here and here. B is 8n, so it's appearing here and here. Just like a appeared in both spots, b appeared in two spots. So again, we need to check, we need to convince ourselves, is this genuinely equal to what's went before it? It is. We can take a look here. So it's 7y minus 8n multiplying 7y plus 8n. The brackets mean multiplication. The first part, 7y, has to multiply both of these. That's happening here. We're going to show that now. And minus 8n has to multiply both terms. We're going to show that over here. So 7y multiplied by 7y gives us 49y squared. Notice the 49 is not in the bracket there. 7y by 8n is plus 56yn. Similarly, minus 8n by 7y is minus 56ny. and minus 8n by plus 8n, so it's minus by plus again is minus 8 by 8, 64, 64n squared. So watching those signs again, the minus by plus makes minus, and again minus by plus makes minus. Those are the rules for multiplying signs. Is there anything that looks the same? Nothing really looks the same there, but please remember this idea here. Minus BA is the same as minus AB. So the YN, NY, they're the same type of thing. They're the same type of term, they're like terms. If I have plus 56 of them and minus 56 of the same thing, that's going to be 0 again, this idea here. So I'm going to get 0 for those two terms. I'm going to be left with 49y squared and minus 64n squared. Can we write that any differently? You can write 49y squared as 7y in a bracket being squared. Remember the bracket here means 70 side square on the bracket means the bracket will multiply by itself. 7y by 7y does give you 49y squared. So they're the same thing. Similarly here, the square in the bracket means that 8n multiplied by 8n will give you 64n squared. So this becomes 7y squared. And this becomes minus 8n squared, but the 8n is in the bracket, the 7y is in the bracket. That's exactly what we started with. So we've seen how to factorise them, seen how to check them, and we've seen these two important points. The minus BA and minus AB are the same, and therefore anything like this will be 0. So looking at another example here, 4n is in a bracket, but there's no bracket here. Well, there's nothing to stop me putting a bracket there, so that's fine, it's the same thing. So let's take a look at this one. This will factorise as a minus 4n times a plus 4n. Simple. And let's check them. So that's the same as that. Now, we haven't multiplied yet. Let's do the multiplication. A by a squared, a by 4n, 4an, minus by plus for the next one is minus 4na, or they're the same thing, remember. And minus by plus is another minus 16n squared. So now they're going to become 0. Just like this thing here. Again, remember that the BA same as AB, AN same as NA. So I'm left with a squared minus 16n squared. But that doesn't look like what we started with, but this part here can be rewritten in a bracket. So it is the same thing. The square says multiply the bracket by itself. 4n by 4n is 16n squared. We've got two questions here. One on the left, one on the right. We've already seen how to do these, so practice them. Give it a go now. Okay, the first one has been factorised. If you've made any mistakes, just take a second to see, can you check the second one there? What should this be? Right, so hopefully you've checked both of them now. Multiply them out to see that they are indeed equal to what we started with. Another common question is, does it matter if the plus is here and the minus is here? That's okay. That won't make any difference. If we have 6a plus 4b in the first bracket and 6a minus 4b in the second bracket, that's the same thing. And we'll just check it. Here we've got the same thing, minus 24 plus 24 is 0. This is what we started with. Doesn't look like it right now, but remember that 6a, when we square 6a multiplied by 6a is 36a squared. 4b multiplied by 4b is indeed 16b squared. So we have the same thing. So this and this are both correct. Right, we've taken a look at a few different examples of the difference to squares. Here we have an example where you'll notice the 81 is not in a bracket and the 16 is not in a bracket. To make this a perfect difference to squares, we need to have everything inside a bracket. So instead of having 81 outside a bracket, we'll rewrite 81 as 9 inside the bracket. Because 9 squared, 9 by 9 is 81. So this is the same as this. Similarly, 4 times 4 is 16. So 4 squared, 4 times 4 is 16. So this is the same as above. This one we can use the difference to squares. A squared minus b squared. My a is 9x. My b is 4y. So I have a minus b multiplying a plus b. So it's a minus b times a plus b. So that's fully factorised. Below here we're just checking our work, making sure that this genuinely multiplies and gives us back 81x squared minus 16y squared. So doing the multiplication, the 9x must multiply both terms here. The minus 4y must multiply both terms happening here. So 9x by 9x, 81x squared, 9x by 4y, 36xy, minus 4y by 9x, minus 36xy. We could have wrote it yx, but yx and xy are the same thing. So this is just nice to keep it xy, keep it consistent. And 4y by 4y, 16y squared. Be careful with the signs, minus plus and minus. So with these two terms being equal but having opposite signs, as 36, take away 36, that's 0. They disappear, they cancel. I'm left to 81x squared and minus 16y squared is still here. So I have the two terms that we started with. So yes, indeed, this can be rewritten as this and then factorised, and if we simplify we get back what we started with. Here's one to try, give it a go. Right, now you've had some time to try 25x squared minus 36y squared. Hopefully the first thing you did is rewrite it something like this before we factorise. So we want to rewrite it before we factorise. You can write that as 5x all to be squared minus 6y all to be squared. So we've rewritten it. The 25 is now 5 squared, 36 is now 6 squared. Now that it's in the form a inside a bracket squared minus b inside a bracket squared, it's in the a squared minus b squared form. Everything here is squared and everything here is squared. When we were given the question, that wasn't the case. 25 wasn't being squared here, so we just need to make sure we rewrite it like this first. Now we can use our a minus b, a plus b. A minus b, a plus b. So my a is 5x, my b is 6y. So that's fully factorised. That's the difference to squares, which was here, has now been factorised. So here isn't really a difference to squares yet. We have to rewrite it. That's the moment when it's a difference to squares. And that's when it's factorised. And we can check it and multiply it out. That's good to do, so please practice that. So I've checked it by multiplying it out and we can see we do get back what we started with. You might notice I have 30xy and minus 30yx. They're the same thing. The order of the variables x and y doesn't make any difference. xy is the same as yx. So that's 30 take away 30 is 0. We're left with our first term and our last term, and that's what we started with. This is a question that might cause problems. We only see one square, so where's our two squares? Remember that 1 is the same as 1 squared, so we can rewrite this. And can we put these in brackets? Yes, we could. So this is ready to go. Our a is x, our b is 1. So our a minus b is x minus 1. The a plus b, x plus 1. I'll let you multiply that on it and check. So we've looked at most of the questions you could be asked. 3 more questions to practice. At the moment, none of them look like the perfect difference two squares, so let's rewrite them first. Pause the video and quickly rewrite each of them. Hopefully while the video is paused, you managed to rewrite each of them looking like a perfect difference of two squares. A squared minus b squared. A is x, b is 1. A is 1, b is y. A is 1 and b is 8k. Try factorising each of them now. Again, pause the video. Now hopefully after a few moments you've been able to rewrite each of them as a minus b, a plus b, a minus b, a plus b, a minus b, a plus b. Each of them can be checked as well. If you want to do that, just pause the video to check. Hopefully after pausing the video you've successfully checked each one. This has to multiply both terms, the minus 1 has to multiply both terms, and you just do your multiplications: x by x, x squared, x by 1, x, minus 1 by x, and minus 1 by plus 1, minus 1. The key thing to notice is the plus 1 and the minus 1 give you 0. The same thing happens all the way through. Plus y minus y is 0. Plus 8k minus 8k, that's 0. You might notice here that the 8k by 8k is 8k squared. And 8k squared is 64k squared. So each of them is checked out, each of them have given us back what we started with. So we successfully wrote each of them as a difference of two squares, we factorised each of them, and we checked each of them by simplifying. So again, wrote it as a perfect difference of two squares, factorised, simplified. Wrote it as the difference of two squares, factorised, and simplified. Pay attention to common square numbers which you'll come across. 1 squared is 1, 2 squared is 4. If you see any of these numbers on the right, you could replace them with something squared. So 49 is 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared. They tend to be the most common ones. 14 squared doesn't come up very often. Squared, not 125, 225 I think. Okay, so these numbers tend to come up quite commonly. But if you're not sure, just check your calculator. Try getting the square root to see do you get a nice square number. What about something that doesn't have a square number? Is this the difference of two squares? Well, you're not likely to be asked it, but we can kind of force it to become a difference of two squares. We could change this to x squared minus square root of 42 squared. So if we really wanted to factorize it, we could do this. Now a is in a bracket, b is in a bracket, we can just go straight ahead with this. This would be a minus b, a plus b. So very unlikely to get a question like that. But it's the same thing. If you multiply that out, you will get this, the thing you started with. We just need to remember that when we multiply root 42 by root 42, it's root 42 squared. That's just 42. The square and the square root will cancel. So notice the square root and the square will cancel each other, leaving minus 42. We have our x squared. And what happens to these? They become 0. Again, notice the order there. I could have put root 42x first. I could have done that. Root 42 followed by x would mean the same thing as x followed by root 42. So that comes up every time. We need to know this, and we also need to know this. So the order of multiplication is not important, the associative property. And things cancel when you're adding and subtracting if you get 0. Okay, thank you very much. Hope that was helpful. Bye.